Welcome everyone. My name is Srinivasa Segu. I am the WebLogic EJB team lead, and my co-presenter today is Marina Watkina, who's the EJB 3.2 specification lead. We'll be talking about enterprise JavaBeans today and tomorrow. Agenda. We'll start with an intro where we'll look at how simple yet powerful EJBs are, following which we'll look at we'll take a closer look at some of the key features that have been added in EJB 3.1. Next, we'll go over what's up and coming in EJB 3.2, following which we'll have a Q&A session. All right, let's get started with a poll. How many of you guys are using EJBs either for work or personally? Wow, okay, that's a lot of them. How many of you guys are using EJB 3.1? Okay, how about 3.0? Okay, how about 2.x? All right, okay, how many of you guys are using CDI? Okay, looks like there are a good mix of people. Hopefully everybody will get something out of the presentation. EJBs today have come a long way since their inception. They're really easy to develop and deploy. From a programming model perspective, any POJO can be used as an EJB. And for session beans, if you want to expose business methods, you can choose to extract an interface and expose the methods through that. Or you can expose a no interface view where the bean class itself is used as your business view. Now, from a client programming model too, it's fairly simple. You can either dependency inject your type of the EJB, which will be the interface, or if you want using the bean class itself, then that would be the type for no interface view. And if you're doing a JNDI lookup, it's pretty much the same. You still expect the same type. You can do the lookup. Now, in addition to that, there have also been simplifications on the metadata front. There are intelligent defaults used for most cases, so configuration is really done by exception. And for cases where you need to provide metadata, you can either use annotations, or you can use XML, or you can use a combination of both annotations as well as XML. And for cases where both are present, then there's going to be a merge that's going to happen. And if there are conflicts, then XML wins. All right. So another area that EJBs have improved on, especially in 3.1, is packaging. Traditionally, EJBs had to be packaged in jar files. So what this meant was, if you have a web application which uses EJBs, you would package all your web content in a WAR file, you would package all your EJBs in a jar file, then you would have to combine your WAR file and jar file together into a YAR file and deploy the YAR file. With EJB 3.1, this restriction has been removed, and now you can package EJBs directly into a WAR file. So this greatly simplifies users who want to keep their all the content in just a WAR file and don't really care about having a separate component for EJB. As far as the classes go, they can reside pretty much anywhere where Java classes can reside in a WAR, which is under webinf lib jars or under webinf classes. And all of them together, even though they're in the jars in webinf lib, they'll be just part of the WAR module. It's not a module in itself per se. For the descriptor goes under webinf, so to keep consistent with the rest of the WAR. Easy access. So another thing that was standardized in EJB 3.1 was standard JNDI names for the different client views. So previously, if you deployed an EJB for exposing the various client views through JNDI, you had to provide a JNDI name, and there was no standard way of doing this. So you had to resort to using vendor-specific descriptors. Starting EJB 3.1, there are default JNDI names that are computed for every session bean that gets deployed for local, remote, no interface, home, and local home views. So it's easier. You don't have to mess with vendor-specific descriptors, and the clients also don't know of the standard naming. Later on in the talk, we'll get into the details of how the names are computed. Unit testing. So one of the complaints that's been around for a while for EJBs was testability. So with EJBs, you had to have a server running, you had to have your EJB deployed, to be able to unit test it. And for local views, it was even more trickier, because if your JUnit was running in remote VM, you needed a remote facade which would invoke the methods on the local view when the JUnit is running in a remote VM. One of the features that was added in EJB 3.1, which we'll get into later, is Embedded EJB Container. With Embeddable EJB Container, you can use your JUnit to launch the EJB container. It will deploy the EJB jars which are there in the system class path, and you can invoke on local as well as remote client views there. It makes it real easy to test EJBs, both local as well as remote client views. Moving on to the powerful aspect of EJBs in the introduction section. So there are several container services that the EJB container provides. Dependency injection, whether it be injecting your JMS resources or your data sources or other persistence units or persistence contexts into EJBs, as well as injecting EJBs into other components like servlets or other EJBs. So there's support for lifecycle callbacks for post-construct and pre-destroy for all session beans and message-driven beans. And for stateful session beans, you also have callbacks around activation and passivation. There's also support for transactionality for lifecycle callbacks. We currently have that for singletons. And there's work in progress to do the same for stateful session beans. There's interceptor support. Interceptors can not only intercept business methods, they can also intercept lifecycle methods, they can intercept timeout methods. It's a pretty useful interception technology. There's also support for transactionality. You can use container managed transactions, or if you want to do programmatic, you can do bean managed transactions. There's method authorization. Timer service has been around for a long time, and there have been a lot of new enhancements that have been done recently for both programmatic as well as declarative timer support. There's persistent as well as non-persistent timer support. And there's also newly added async invocation support as a part of EJB 3.1. We'll get into the details in one of the sections. EJB being the core component technology here, it's been well integrated with the various platform specifications. So singleton as well as stateless session beans can be exposed as REST root resources. They can also easily be exposed as JAX-WS web service endpoints. And when CDI is enabled, it recognizes session beans and has first-class citizens and deals with the contextual lifecycle management as well as injection. All right, so we have a demo here which kind of demonstrates what we've been talking about. All right, so hopefully, are you guys able to see this? Okay. All right, so here's a simple new registration page, new user registration page. The UI is fairly rough. The UI as well as the persistence layers are kept simple intentionally because the focus is in the middle tier here. So you can create a user, so Java1 web user 1, and give some password. And it registers the user, and I missed a B there. Okay, and it shows you the same page again to register another user. So now if you go back to seeing what it takes to do this, so we start off here with a user registration servlet, and we don't have a middle tier, so we inject an entity manager factory directly into your servlet. And you have to inject entity manager factory because that's the thread safe component, and you can't really use a entity manager since servlets can be accessed concurrently. So you also inject a user transaction object. You get your name from the request parameter, and if it is there, you call on to a register user method. And the register user method, as you can see, creates an entity manager out of your entity manager factory. Then it begins the user transaction, makes the entity manager join the user transaction that was begun, and then calls persist on it and commits the user transaction. For failure cases, it does a rollback and it closes the entity manager. So there's a lot of work that's happening here for just being able to persist the entity. Now, if you want to switch this over and start using EJBs, I've already coded up a EJB cert. We don't have to spend too much time on it. But here's a user registration service, which is just annotated at stateless. And you inject an entity manager into it directly because the container takes care of making sure that there's only one user accessing the particular instance of the stateless bean. So you have the create new user method, and all you do is em.persist with the method being transactional by default. This should take care of it. I'm also logging a element to the system.out to be able to see it from the log file, but obviously it's not really necessary here. So now if you want to switch over this to be able to use your EJB, here's all the code that you'll need to do. So you go here, you get rid of your persistence context. You don't need your user transaction anymore. You just inject your EJB and then in your actual method, so you go over to the register user method that you had here before, and you can start using the user registration service. I get rid of all of this. And do create new user with username and password, right? So here you've started using your stateless bean, and now I'm going to switch over to building the simple demo and redeploying it. Okay, and now hopefully this is going to work. So I go back to register new user. You say Java 1 web user 2 password 3. All right, so we've registered web user 2, and we can also probably look at the recent. So hopefully you can see the server log here, which shows that the so here's, you see that it's going through the EJB service that we just added and doesn't go through the servlet that we had before. So if you look at this, it simplified a lot of this stuff. It took care of the transactions. It took care of the registering the entity manager with it, and you can just inject the entity manager. It really simplifies stuff. The client programming model, all you had to do was inject. You didn't have to extract an interface. It's a plain Jane Pojo, and you had stuff here. So now, if you want to say, for example, start exposing this as a as a web service, all you need to do as a JAX-WS web service, then all you need to do is add web service here, and that's it. And then go back here, do your rebuild, do the redeploy. Okay, so if you go back to your server log, you'll see. Okay. Looks like there's, okay. So here's your web service, and now if I do a new page, so for web services, Glassfish provides a tester page, which you can use if you don't have a client, but otherwise you'll have to write a web service client for this. But now you can do Java 1 web service user 1 and password 123. So create new user. So there's no return value, but you see that you can use it as a web service. Now if you want to do it as a JAX-RS web service, there's a little bit more work that you need to do, but it's really at the metadata level again. So you add a path so to say where it needs to be exposed, and you mark it as, say, for example, post method, and I'm going to replace this instead of typing it for you. So, and then talk about what I just did. So I added a add post annotation saying that this is a post, and this is a query parameter which is going to be username, and there's another query parameter which is going to be password. Right. So now if I want to rebuild it here, and then if I want to do a deploy. Okay. So again, for JAX-RS2, there's been no effort done in the UI, so it's a bit rough again. So we are using Postman, which is a RESTful web service client. So here I have this service. I can create, say, JAX-RS-user-1. I guess I missed Java 1, but that's fine. So I do a password 123. I do a post, and I send, and I can send it up. Oops. Looks like something's request to resource is not available. All right, let's look at the logs. Let's look at the primary key. Okay, that seems fine. Okay, let's look at what are we using here. Oh, you know what? So yeah. So another thing that you need to do when you're doing a JAX-RS client is, in addition to actually annotating the UJB, you'll need to create a application class, which is needed for Jersey to be able to detect the resource. So here in my demo notes, I have that copied, so I can copy it here, paste it here. All right. So all you see here is the get classes returns the user registration service, which is our EJB, which is exposed as JAX-RS. Oops. So let's do a deploy here. Hopefully it's going to work this time. That's all it needed. Yes. No?
Did you got the resources?
I have the application path, I have the user registration service here. Okay. Hang on, let me see.
Did you got the resources in the URL?
Let me see if you have user registration service. Okay, did I have resources here in my application? Yeah, I have resources here. So anyway, I mean, I think we don't have time. I can look through this while my co-presenter is presenting and show you. So it's fairly easy to even expose it as a JAX-RS resource. It doesn't really take much to expose it as any of the web services. Now, all in all, there have been a lot of complexities addressed to make EJBs real easy to use, and the container is fairly feature-rich and well integrated with the platform. So moving on, let's take a closer look at some of the features that have been added in EJB 3.1. So here, in this section, we'll look at the individual features. We'll talk about singleton session beans. We'll talk about asynchronous session bean invocations. We'll look at what has been added newly in for the EJB timer service. We'll look at how the portable JNDI names are computed. We'll also look at what it takes to use the embeddable EJB container for whether it be testing or running in a J2SE, Java SE environment. We also will look at EJB 3.1 Lite, where we'll look at what are the features that are part of the EJB 3.1 Lite. So moving on to singleton session beans. So this is the first time that a new session bean type was added. It was part of EJB 3.1. So for singleton session beans, as the name suggests, there's one instance created. However, there is one instance per JVM. So if you have it deployed to a cluster, you would expect one instance per JVM on each node of the cluster. So the singleton session beans are intended to model the use case where state needs to be shared across different clients. While it has its own set of features, it has a lot of commonality with other session beans too. It's inherently designed for concurrent access because it's intended for sharing state. As far as commonality with other session beans, you see that it exposes no interface, local, remote, as well as JAX-WS and JAX-RS client views. It supports container managed transactions as well as bean managed transactions. The same container services, whether it be method authorization or timer service or all the other EJB timer services, continue to be available for singleton session beans too. So here's a POJO, which is named app config bean. It stands for application configuration bean, shortened to be able to fit on the slide. And then you have config data, which is which you can think of as the in-memory representation of your application configuration. And the assumption is that you have a post-construct method, which is not shown here, which creates the config data. It could be populated from a properties file, from an XML file that you guys have, or from, say, a database. And you have a get config value, which takes a key and return the configuration corresponding to that. And similarly, you have update configuration values, where if you want to provide a way for users to be able to update the application configuration, whether it's sysadmins or whoever. So now, if you need to make this a singleton, all you need to do is add the @singleton, or you can do the same through the descriptor. So as far as the client goes, it's fairly simple too. All you need to do is use your @EJB, and you can inject based on the type. In this case, it's a no interface view, so we use the bean class, which is app config bean. Now, so we talked about how singleton session beans are designed for concurrency. So there are a couple of concurrency options. You can use container managed concurrency, or you can use bean managed concurrency. Container managed concurrency is the default. So for container managed concurrency, the expectation is that the user is going to provide the locking metadata as to what kind of locks are required for each of the methods, and the container does the actual locking. So the locking style is read-write style locking. So concurrent reads are allowed, and writes are exclusive. And the locking metadata can be provided through your descriptor or through annotations. And if you're using annotations, you can do it at the class level as well as override it at the method level. By default, all methods are write locked, so the singleton session bean is thread safe. Another annotation / metadata that's available for container managed concurrency is access timeout, where if you want your lock request to timeout of a certain amount of time instead of waiting forever, you can use your access timeout annotation. As far as reentrancy semantics go, a write lock holding thread can re-enter for read or write, and a read lock holding thread can only re-enter for reads and cannot upgrade to write lock. It's very similar to what you would see with Java ETL concurrent if you're familiar with the reentrant read-write locks. So we get back to the app config bean that we looked at before. We annotate it at singleton, and we look at the get config value. It's a read method, so we say, all right, we're going to specify that this method needs to be read locked, and we provide the access timeout saying that the access timeout for this guy is 500 milliseconds. Now, update configuration values is doing a write, so we provide the metadata saying that you need to obtain a write lock for this. So the user just provides the metadata, and the container takes care of doing the actual underlying locking. So the other option is bean managed concurrency. So with bean managed concurrency, the container does not do any locking. So any incoming invocations will get access to the bean, and it's really up to the bean code or bean developer to make sure that the instance state is accessed in a thread safe fashion and mutated in a proper fashion too. So he can use any of the options here. He can use Java ETL concurrent lock APIs or synchronized or volatile or any other mechanism that he sees fit to make sure that the bean state is handled correctly for concurrent usage. So here's an example. So you have a cache bean, so you specify one of the new things that you see here is you do specify the I guess concurrency management type as bean because the default was container, and then you see that the user can use synchronized here, and in this case you can see that he can do finer grained locking than the method level. He's doing some computation after which he's going to try to acquire the lock. So that's one of the benefits of using bean managed concurrency, that you can do finer grained locking. So initialization and lifecycle. So singleton session beans, like other session beans, get post construct as well as pre-destroy lifecycle callbacks. One of the things that is unique about singleton session beans that we kind of alluded to before is that the callbacks are transactional by default. So whatever is your beans transactionality, if you set it to be container managed transactions or bean managed transactions, the same apply to post construct and pre-destroy. So the key benefit is you can do transactional work as a part of your construction and destruction now. So one of the other things that has been that is unique to singletons is they have an at startup annotation. The at startup annotation. So by default, singletons can be initialized whenever the container needs it. They can be initialized eagerly or they can be done lazily. The at startup kind of is a mechanism for the user to say that I want this singleton to be initialized eagerly. Now, what this provides is if you combine your at startup annotation with your at post construct, it turns out to be your application startup callback. So as a part of your deployment, when your application is starting up, the container tries to initialize your singleton because you marked it as at startup. And now since you have post construct there, it's going to invoke the post construct. So if you want to do anything as a part of your application deployment for that particular singleton, that would be a place to do. Pre-destroy for singletons for any singleton that has been initialized, the container does the pre-destroy callback as a part of the application shutdown. So that would be a place for anything that you want to do as far as shutting down goes. Now the key here is that it needs to be a graceful shutdown and the bean needs to have been initialized. Otherwise you wouldn't see a pre-destroy callback happening. So here's an example of a singleton session bean which uses at startup. It's a cache bean and it has a post construct annotation on a prefetch cache data, which you can think of as the method which would load up or pre-populate your cache. So even your first hit to your singleton cache wouldn't take any additional time. So the setup of the cache happens as a part of the deployment. And you have release system resources, which you can think of a method which as the one that would release any system resources that it's holding on to, which would happen as a part of your pre-destroy as a part of the application shutdown. So another feature that is unique to singleton session beans is at depends on. So singleton session beans can express their dependencies on other singleton session beans using the add depends on or the descriptor equivalent. And when a singleton session bean declares this, the container ensures that all the beans that this particular singleton session bean depends on are initialized before calling the post construct for this particular bean. And the same holds for pre-destroy, that when the pre-destroy for this particular bean is called, its dependencies are still available. So if you have a session bean A, B, and C, A depending on B and B depending on C, then C would be initialized first as it doesn't have any dependencies, then B would be initialized, following which A would be initialized, and the destruction order would be reversed, where A would be destroyed first, following which it would be B, and then it would be C. All right, switching gears. So the next one is async session bean invocations. So before EE6, if you had to do asynchrony with EJBs, the option was to use JMS with MDBs, which was fairly heavyweight if all you needed was lightweight asynchrony. With EJB 3.1, asynchronous support was added for all session bean types. By default, all session bean methods still continue to be synchronous. So you can add either at asynchronous, or you can use the descriptor equivalent to make the method asynchronous. And when you mark a method as asynchronous, as you would expect, when you call the method, the control returns back to the caller right away, and the execution happens. Execution gets scheduled and happens at a later time, or concurrently on a separate thread. So there are no persistence guarantees here, unlike JMS. It's really lightweight asynchrony. As far as method authorization goes, it's very similar to synchronous calls. You can still use declarative as well as programmatic security. Security does get propagated of the caller. As far as transactions goes, there's no propagation of transactions from caller to the callee. So if you have a method which you're marking as asynchronous, the caller's transaction doesn't get propagated, and you'll still end up creating a new transaction. Your remote, local, as well as no interface views, all of them support asynchronous methods. You mark a bean method as asynchronous, so all the client views through which it gets exposed will be asynchronous. So for asynchronous methods, you really have two types of returns. You can either have a void returning type where the caller doesn't care about the return. It's kind of a fire and forget style. Or you can have a Java util concurrent future returning method where the caller does care about the result. So let's move on to a quick demo. How are we doing on time? Okay, all right. So let's come to async here. So the first one, I'm not going to go into a demo. I'm just going to show you the code. So you have an employee object, which is a entity, which is a persistent entity, and you have an employee management stateless session bean, which you can imagine manages employee objects. So here you have an add new her method, which takes an employee, and the first thing it does is it persists the employee. In addition to persisting an employee, there's a lot of other stuff that you need to do when you have a new hire. You want to create a mail account for them, you want to order a desktop, you want to order office supplies. There's a lot of other tasks that need to be done, but they don't need to be done synchronously. So here's an example where you have all these methods that get invoked, but all of them are asynchronous. So the call returns right away. It schedules all these tasks and returns right away. So here's an example of the void returning. Now let's look at something that showcases the future returning type. So here's a report generator bean, which has a generate header, which has a generate body, which takes a start and end index as arguments, and there's a generate footer, which generates the footer. So in this case, you see that all we are doing is sleep, but in a real world implementation, you would have the actual computation here. So another thing that's of interest here is the async result object. So async result is a convenience class that EJB container, Javax EJB API provides, which can be used to wrap your result into a future. This never gets to the user. It's just a convenience so that you can keep the same signature on your bean class as well as the interface. Now, if you look at the calling code for this, okay, you have you have a report generator servlet here, which injects the report generator and then calls on it and says, generate a header for me, generate a body for 1 to 1000, and 1001 to 2000, 2001 to 3000, and 3001 to 4000, and a footer. It creates all these futures and then says, okay, I'm going to iterate on all the futures and do a blocking get sequentially, and all of these are going to be executing parallelly. And then I get the results, I append it to a report, and write it out to a response output stream. So let's look at this demo. Hopefully this will work now. Okay, I'm going to deploy the async demo var. Okay, so let's go to localhost and so here's the async example. Let's see how long it takes to load up. 1 Mississippi, 2 Mississippi, 3 Mississippi. Okay, so our report got generated a bit faster. So 5 seconds. Since we were just doing sleep, all of them ran concurrently, and we were able to get back pretty fast. So this is an example where you use a future API as a return type. So now for methods that are using Java ETL concurrent future, you have the ability on the future to check the status, whether the call has been completed or if it's been canceled. You also have the ability to get the result like we saw. You can do a blocking get, as well as you can do a get with a timeout if you want a timeout after waiting for a certain amount of time. Now, there's also ability to retrieve the exception. So your get call would throw an exception, which would be of type execution exception, and you can do a get cause on it to get to the underlying EJB exception. There's also ability to cancel. Cancel takes an argument to interrupt if running. For the EJB implementation, the container is not expected to cancel if an invocation is in progress. It's only expected to cancel if the invocation hasn't started yet. So if you get a future and you call a cancel, you're not really sure that the cancellation is going to succeed. There is a return value which tells you whether the cancel has succeeded or not. However, the maybe if interrupt running has a useful functionality here. If you pass that in as true, then in your bean code, you can use session context and try to check if that particular invocation was canceled and do the cancel, try to return. So here's an example of that. So you have a doc processor which does transformation. It takes a collection of doc inputs and it's marked as at asynchronous. As it iterates through the various docs, it checks if any of the doc was, if the invocation was canceled, at which point it just breaks and returns from there without continuing the execution. There are changes in this area that Marina will allude to, which are being planned for EJB 3.2. I think with that, it's EJB timer service, and Marina Watkina will continue the presentation from here.
Hello. We're a little bit behind. So, do I need this thing?
No.
How many of you are using the latest and greatest EJB timer service? Okay, we will go through this. How many of you know details of standard global JNDI names? Okay, we will rush through that. Embeddable container. Okay, I'll quickly. And EJB Lite. Okay, let's see how. What can we do? Worst case scenario, I will rush through the EJB 3.2 stuff. So the timer service. I can't see it here. So timer service divides into programmatic timers and automatic timers. Programmatic timers is when you create timers in your code using timer service API, and automatic timers will be created for you by the EJB container deployment. There is misalignment. Both of them can be persistent and non-persistent. Obviously, persistent timers is the timers that container stores somewhere, so that if the server crashes and restarts and there was a missing timeout, the container will make sure it is executed. For the non-persistent timer, the container has no knowledge while it's down. They differ on the behavior between programmatic and automatic timers in what happens. So programmatic timers are single action. You just define the date or the interval after which it fires, and that's it. It's end of its life. Interval timers, it's all old stuff. I'm just, for the sake of the picture, repeating that. Interval timers is obviously timers that run at a specific interval. And calendar-based timers is something new in 3.1. I'll go into more details on next slides. For persistent timers, there is a single timeout method on each bean. So how many timers you create from that bean, all timeouts go to the same method, annotated with timeout. And non-persistent timer, if container goes down, unless you re-execute the method that created that timer, it's gone, okay? Because there is no knowledge. Now, automatic timers are always calendar-based timers. There is nothing else. Calendar is like cron style, so you can do a lot of things with it, but that's the only way. Each at schedule or schedule and deployment descriptor defines the timeout method. So you can have as many timeout methods in your bean as you have schedules, or you combine several schedules on the same timeout method. And so it will execute for each schedule. Each schedule is completely separate. Now, when a calendar-based automatic timer is deployed into the cluster, then a persistent timers is guaranteed to be run only on one instance in a cluster, independent of the number of instances. And non-persistent timer will be running on each and every instance because instances don't know about each other. And what's interesting about this, also non-persistent timers are restarted. So if you canceled it during the execution, container crashed or container was stopped, restarted, your timer is created again. So what are calendar-based expressions? There are no nanoseconds. Seconds is the lowest denominator. They are obviously normal digits. What's interesting here, second, minute, and hour default is 0. So if you don't specify anything, it will be midnight. And if you specify hour only, it will be at the top of the hour. Year, obviously, is for digit. So the rest is the day, year, month is default is star. So midnight of every day is pretty much a default timer. Day of the week, 0 and 7 both Sunday, denotes Sunday. Or you can use standard English 3-letter abbreviations. And month is, obvious choices. Now, this is more interesting. You can specify day of the month as normal day of the month. And if you specify 31 for February, it will fail. You can say last, whatever is the last. Or you can say choose up to 7 days before the last. And the container will calculate each month what it means. And you can have a combination of an order and the day of the week. It can be last Sunday, first Monday, third Tuesday, and such. And default, as I said, always every day. You can combine those options into some rules. Obviously, there is a single value. List is a comma-separated values. You can have a range, and the range can go over the end. So here it is from 27 to whatever the end of the month, and then to the 3rd of the next month. And for the day of the week, you can also have Friday to Monday, which will be Friday, Saturday, Sunday, Monday. So wildcard is obvious increment. This particular example says starting from the beginning every 10 minutes. But if you say start with 5, it will be 5, 15, 25, 35. And you can have list of ranges, and in that list of ranges can be single values, mix of ranges and single values. I'm sorry if I'm rushing through, but we have a long thing to go through. So it's past already noon, but the timer that would have expired today at noon can be specified as hour 12, day of the month 2, and month October. It can be specified as hour 12, day of the month, first Tuesday, right? Today is the first Tuesday, and month 10, which is the same as October. It can be on any second of day of every month at noon. It can be on any Tuesday at noon. It will still have expired today at noon. Obviously, every day at noon. or every Tuesday and Friday at noon would have expired today at noon. So, an example, for automatic timer, you would use schedule annotation, and this is another option of today at noon. This is every first month in a quarter, first Tuesday in a quarter. You know. And the schedule will denote your timeout method. For programmatic timer, you will use schedule expression with Fluent API to create an expression. Then you would use timer service to create a timer, and you will specify the timeout method on your bean. You can see that the first one is no arg, and the second one has timer. These are your only two options. Timeout method can either take a timer, and with EJB 3.1, this was relaxed and said if you are not interested in the details of that timer, you can have a no arg method. Portable JNDI names. This is a very useful feature if you are porting your application from one app server to another, because now you don't need to figure out how each app server creates its JNDI names. There are always default, for each EJB, there are 4 types of standard JNDI names, but we will look into Java :global first. So the prefix is Java :global. No, that's not what I want. Okay, so app name is optional. It is if you deployed your bean into an ear, inside an ear, then app name is present. If there is no ear, if it is a war or jar that you deployed, then app name will be missing. The slide is not quite right. So module name is the name of your module, and you can override the app name in your application XML and module name in EJB jar XML or web XML, because it will be the name of the war, and both types minus dot suffix. And bean name is your unqualified bean name by default. If this bean exposes only single view, remote, local, no interface, doesn't matter. That's enough. You don't need anything else. If it exposes more than one view, then you, for each view, each specific view that you are looking up, you would say $ and then the fully qualified view name, which is for no interface view will be the bean fully qualified bean class name. And obviously, this is for local and remote, and no interface, as I said. And there are shortcuts for Java :app to look up in the same application, and Java :module in the same module. So if you have a hello bean that you deployed the long way inside my module jar and hello ear, it will be Java :global. Hello is the name of the ear, my module, the jar, and hello bean. Inside that ear, you can look it up from a different EJB or servlet that is in a separate war, Java :app, and then only the module name and the bean. And inside the same module, this bean is available without any knowledge of the packaging Java :module hello bean. So if this bean implements an interface, and assuming it also is marked as local bean, that particular view will be with the fully qualified interface name. Embeddable EJB container. So Srini mentioned that embeddable EJB container is something that is intended for testing. It runs in the same VM as your unit test. We don't have time for the demo. So there are very simple API. You create EJB container. By creating EJB container, the embeddable EJB container, in your VM, at the same, you don't deploy anything. This magic method scans the class path for any directory or jar that contains EJBs and deploys them. If there is a single jar, it will be a single jar. If it is several jars, RI will create an ER file for you in the background. So when this method returns, you have all EJBs deployed. You can pass a map to this method to choose specific module or to choose specific file to load. But by default, the whole class path is scanned. You can get the context. You can look up your local EJB. That's the most important thing. Otherwise, normally you have only a remote client before that. If you deploy to a regular server, you can do this only from inside that ear, or inside the jar, or from a remote client. And you call your local bean method, and you don't forget to close the container to release all the resources. And we should make it closable in 3.2. But again, the main idea to be very easily testable, and the container is portable. I mean, with 3.2, we clarified that not each vendor is required to provide the embeddable EJB container, because let's say a cloud vendor does not have a notion of your local testing. But most already provide, so we don't think it is that big of a deal. Okay. EJB Lite is a subset of features that is available with Java E6. You have web profile and full profile. With EJB packaging in a WAR, you can have, just the WAR file deployed. And in web profile, this is the list of features that will be available to your EJBs. And the bottom is, simple GAP, security, transactions, interceptors. The important thing is this: only local views are available in the Lite. And Lite is a guaranteed set of features in the web profile and embeddable EJB container. So it's guaranteed to be testable, only EJB Lite set of features. Okay, and now we're going to the future. So EJB 3.2 is work in progress. It's GSR 345, easy to remember. EDR is published on the JCP side, but because we are under 2.8 JCP rules, we have everything in the open. You can subscribe and tell us your opinion on anything. You can, and users alias receives a copy of all expert group discussions. You can search archive. You can file issues, and you can download the latest and greatest version of the spec that is not updated. On JCP, there are like 3 of them, and I upload, as soon as I have time, I upload the next version to the EJB spec project. So the main themes are continue with ease of use, obviously. We remove unnecessary restrictions. For example, EJB spec up to now is still saying that you should not access files. How many of you are accessing files from EJBs? Okay, we removed that restrictions. We removed restrictions to access the context class loader. We went a little bit through that list. So if you have your pain point, subscribe to the user's alias, send us a note. We will look in this. If it's obvious, we will remove that restriction. We move away unused features, optional features, there will be a separate, and we clarify. We go with a comb through the spec and say, okay, how do timers work in a cluster? What is expected from distributed timers? What is expected, how transactions and interceptors? Let's make sure that the spec is very clear in each point. What's new? Stateful session bin lifecycle callbacks can be now made transactional. For backward compatibility, they are not. So you need to opt in by specifying transaction attribute requires new. And it always requires new because even in the singleton, lifecycle callbacks run in post-construct run its own transaction. And the same thing is for pre-destroy. If you need to make it transactional, you can opt in and you can do it with the deployment descriptor as well. You can opt out of passivation if your stateful session bean needs to stick around, or it has non-serializable fields that will cause a crash and removal of the bean during passivation. You now can opt out of it. We simplified the rules, relaxed the rules on defining all views of the bean. So if in our example, bean A implements two interfaces, and besides what is there on the screen, nothing, no annotation or no deployment descriptor say anything else. So foo and bar do not have any, they're not denoted in any way but on their own. Then foo is automatically a local view, and bar is automatically a local view. You don't need to have that at local foo.class, bar.class. Obviously, if your bean is explicitly marked as local, it is the same as the previous, because by default, a bean is local. So both foo and bar, unless they are denoted otherwise, become the two local views. And the same for remote. If your remote bean implements several interfaces, and those interfaces don't define anything, any rules of their own, they automatically become remote interfaces. Timer service got a new method, get all timers, to return all timers in the same bin. They are for displaying purposes, because the limitation is that only the bin that owns the timers can cancel them. MDBs got alignment with GMS to O, and we enhanced the list of standard activation config properties by just defining them. If you use them, they will be recognized. EJB 3.2 Lite got two more features in its list. Local asynchronous invocations, we found them useful to be available in the WAR files, in the web profile, and non-persistent timers. So with non-persistent timers, if your app has programmatic persistent timers, at deployment time, the container won't know that. So the app might fail later on. With the automatic timers, obviously the container won't be able to create them. It will fail fast. So these two features will be available in the web profile and testable by the Embeddable EJB Container. Removing features. So EJB 3.1 marked 3 sections as proposed optional, and we're making them really optional. And not only optional, we're moving them to a separate book of its own 200 plus pages, which reduces the size of the core document, because they were like in the middle and you needed to kind of go through them without any use. So CMP, BMP, and JAX RPC are now optional. Your vendors, EJB vendors, are not required to support them. But if they do support them, they might support CMP as a whole CMP. They can't pick up like EJBQL and provide it by itself. It needs then to provide support for the CMP. Okay, the rest is a discussion in progress that you can vote still on and voice your opinion. As Srini mentioned, the future cancel right now works if you want to short circuit your execution of a very long-running async method. The only way to do that would be to check the session context. But if you call another bean, that bean's context is synchronous and you can't check it there. So what we are discussing is actually interrupting a thread. Then your code will be able just to use normal JDK to check if thread was interrupted. And then the other interesting part is that if this do next part was waiting on a queue or some other interruptible condition, it can now be, will get that interruption and won't wait forever until your code is executed. We are discussing the details of backward compatibility, but most probably this thing is in. The rest is really under discussion. How are we doing? We have 5 minutes. So max concurrency is something that people were asking. It's not clear for us how to define for asynchronous invocations. Because if you have 10 asynchronous methods and each of them will define its own pool or point to the same pool and say max 10, they might just exhaust the pool by themselves. We are trying to figure out what to do about that and how to define the behavior when there are no threads, then what asynchronous method should do. Client choice of whether to call synchronous method asynchronously. This is a tricky thing, but JAX-RS, now adding async, will define an API how to choose whether to call a method synchronously or asynchronously. JAX-WES does code gen, so you can choose, but in EJB, you can convert a synchronous method into synchronous by doing future get if it returns future, and block forever. But you can't say that synchronous method, I'd rather run at this point asynchronously. There is no way. We're trying to figure out what to do about that, but we don't want to make it ugly. Crystal ball, if you're asking what's the crystal ball about the future of EJB, it's decoupling components and enterprise services, eventually making enterprise services of EJB by default available on EJB, but an ability to opt into them in other managed beans. The first step is CMT, Container Managed Transactions on CDI beans, that is being discussed. At this point, it seems that EJB will continue doing what they were doing before, and CDI beans will use the new interceptors, but there's still some clarification that need to happen. The next thing that will probably become decoupled is the timer service, not necessarily in this release. CMT proved to be not as straightforward as we thought. Log startup depends on from singletons is quite useful to be available on other beans. And another part of this discussion, whether they are CDI managed beans only or all managed beans. Bean method validation from bean validation. EJB will support them in 3.2. And the decision is, it's not yet in the spec, in the latest version of the spec, it's kind of an agreed upon item that even if CDI is not enabled, it will be available for all EJBs. An interesting talk today at 1 here in the Powell, I think. David Blevins is the proponent of improvement in the non-GMS MDBs, connector MDBs, to make them cool and JAX-RS style. It's an interesting proposition. If you didn't sign for anything else, go today at 1 and listen to David talk. There are other items in the pipeline to become proposed optional if you don't know what. So it's a two-step process. You can't make something optional right away. They need to become proposed optional, and then maybe in the next release or release after, they will become really optional. So there is enough time for developers and vendors to prepare. So 2.x home and component views might become optional eventually. They will become optional eventually, but the question is when. All remote client views, the route right now is to move to web services as the clients. So there is a discussion of removing a remote client from EJB spec. And interop, there is a big push to make it optional. Probably not as much from developers as from vendors, because supporting interop is a big pain. And we're like 1 minute before an hour, we're done with the presentation. These are reminders where you can get all the information about the EJB 3.2. Other questions? We have 30 seconds. But yeah, we can probably stay a little bit, and we can definitely take questions outside.
What did you mean by removing interval?
Thank you.